Today we'll be learning how to structure C# code into layers per clean architecture. In advance of today's exercise, you'll want to install .NET 5.0 and Visual Studio Code. If you're unfamiliar with service-oriented architecture or clean architecture or onion architecture, there's some great write-ups on this. We are currently looking at a document from Microsoft which illustrates this, and that link will be in the description below. To begin, let's create a new directory for today's exercise, and let's open up a terminal instance to that directory. Let's demonstrate this architectural approach using a web API project. We can do that with .NET, new web API, we'll output that to source. We'll have the benefit of naming the project source as well. If you want a different name, just change the name. Then we're going to want to open this directory in Visual Studio Code. There's some pre-generated code in this template. You can pretty much ignore that right now. Let's move forward by creating a new folder. We'll name that core. Core is going to be a directory where we store most of our main domain entities or contracts for things including services or repositories. So interfaces for the infrastructure layer as well as for the sort of business logic oriented services. And so we'll, in this directory, create our first POCO, which will be just an entity that describes what is a contact. So contact.cs. And in here, we can draft up a new class. So here we have a contact. It's got a name, a number, that might be a phone number, and a type. So maybe that's a company or a person or a business, maybe is another term for that. We can use that to define what is a contact. Next, we're going to want to create an interface for a contact repository. The iContact repository. We're going to want the ability to retrieve and create a contact. So this will be a nice contract to be able to do either of those activities. So now that we've got our infrastructure contract down, we can create a business logic contract. So we'll do an iContact service.cs. Within this, we can put our contract for interacting with any business logic concerns. And that'll look pretty similar. It'll look like a retrieve and create as well. There'll be some logic in the create maybe, and that'll then forward onto the repository to actually do any interaction with a data store. Now let's implement the service contract. We'll do that with a new file called contact service. Now I've gone ahead and implemented our contact service. In this, we've got dependency injection, passing in the infrastructure that is a repository implementation. And if that doesn't work out somehow, then we've got a catastrophic issue. We should have that be an exceptional case. It means dependency injection is not configured properly, so we should verify that. Going on to retrieval, we've got a name that's passed in, which is the name of our contact. Maybe that's an ID if we wanted to do that a different way. And if that name turns out to be empty or null, then we'll return null. That's some logic a little bit there. Otherwise, we'll just return the retrieval from the repository. And similarly with create, we've got if that entity is defaulted, aka the contact doesn't actually exist or isn't implemented, maybe this is null in this case, then we would consider that to be an invalid operation. And we've got this other interesting case, which is if the entity type is business and the number is null or empty, then we consider that to be an invalid operation as well. You could go about this a different way. You could have this be a string or some error type and pass that up without having to use exceptions. In this case, we're taking the lazy way out and just relying on exceptions to handle things. Probably not the best thing to do, best practice, but for today's exercise, it's easy to implement that way. Then we'll create, just return, what is the void type after creating in the repository. And these are all of our core concerns. We've got the entity, a contract for a repository infrastructure, contract for a service, business logic, and then we've got the implementation of our core service here. The next thing we'll need to do is implement the infrastructure concerns, which in this case would be the contact repository. And we'll do that in a new folder called infrastructure. In infrastructure, we'll create a contact repository.cs. And here we'll implement it. And here's an implementation of that contract. So in this instance of the infrastructure, we've defined a contact repository to work off of a concurrent dictionary. And you might think, hey, where's SQL? Where's Postgres? And that's sort of the beauty of the architecture of the pattern here is we can swap in and out different implementations of the infrastructure. So if we wanted to instead use Postgres, we'd just implement this one contract, this one class, in a different way. For now, we have a concurrent dictionary. With both the infrastructure and core concerns defined, we're ready to move on to the startup.cs here and define and implement the dependency injection for that code. I've added a scoped implementation of the iContact service, which is the contact service, and I've added a singleton of the contact repository as iContact repository. The reason I've done a singleton here is that we're using that concurrent dictionary. If we're using a different implementation, we might actually change this, but for now, I think that'll work fine. Next, let's expose the service through a controller. That'll function as a UI layer in this case. We can create a new file in here, contact controller. And in here, we'll implement that controller. Our contact controller just knows about our service. Rather, it doesn't even know about an implementation of it. It knows about the contract for the contact service. It gets injected through dependency injection as we defined in startup.cs. And for get, just returning the result of retrieve or create. We're just going to run that create. From there, we can open up the terminal, run this, and see how it does. Going back into the terminal instance in our directory of the day, we can run .NET run, pass in the project argument, which is the source directory, source.csproj. Once that builds and runs, we can navigate to localhost 5001, and we can go to /swagger and play with our application. Let's try this get endpoint. We currently should have nothing in the concurrent dictionary. So if we try non-zero as a key, we shouldn't get any result, and in this case, that's accurate. We go down to the post, and we try that out. We can change the name to non-zero, change the name to nothing, and the type to maybe person. In fact, that returns 200. That's a success. Up here, we can execute, and we get a result. That's good. If we were to instead make a business, maybe it's non-zero Inc., and then the type is business. Remember that this was an error condition. And in fact, we get an error here. Looking back at the code, we implemented this in a single project. And in C#, it's very possible to create new class libraries and separate different concerns into different deliverables. So we could have a different class library that just contains the weather stuff if we wanted. I tend to prefer simplicity for smaller projects, and so I implemented all of this in one project today. However, in larger solutions, larger projects, perhaps you would have like a monolithic large application. You would have a lot of different CSproj files and therefore a lot of deliverables. And in that case, you might simply implement infrastructure as its own CS project and core as its own CS project. And that would be completely appropriate. At that point, it's just a matter of startup having references to each of those, and controllers, knowing about core, and that would allow you to implement the same solution using 3 projects. That would be completely appropriate. Today we implemented a clean architecture application. We did so with a web API. We talked about what different separations would be necessary and where different dependencies would lie. If you have additional time, you might check out one of either of the links in the description below. We have Uncle Bob's Clean Coding write-up, as well as Microsoft's Clean Architecture blog post that has things like diagrams and stuff. If you don't have that extra time, congrats on a non-zero day.